Alright guys, hopefully this video is a little bit shorter. I know that the first one is an introduction, so it kind of has to be a little bit longer, but I think it was also not too bad. This one is going to add a little bit to what you know. You already should be very familiar with what an equation is, what an expression is, what the different parts are, and the idea of combining like terms. If you don't know any of those things, either ask questions or go back to the previous video and make sure you do understand. Here we're going to get into substitution, and this is something that you will use all the way up to, even into university. So you're going to use it throughout high school. You're going to use it, even just to check your answers. This is how you know whether you got a math question right in 9th grade, 10th grade, 11th grade, all the way up. All right, it's much easier than it sounds. Substitution is just putting one thing in for another. That's what substitution is, right? You substitute something. For example, if x equals 3, like it does here, you would just put a 3 every time you see an x. Okay? Sounds simple, because it is. All right, so let's do a couple quick examples, and then we'll push forward. So what we have here is two different variables, and we know what they are. So we have these equations that these expressions that we've set up previously, and we are just going to put in the value that we figured out. So x equals 3, we're just going to put 3 in for every x that we see. All right, so 5 plus x is 5 plus 3, which is just 8. Easy as that. Here we have 2x. Remember that when they're clumped together like that, that means times. It means 2 times x. And when you are doing substitution, sometimes a good thing to do would just to put parentheses. You should put parentheses there to, especially when they're negative, because it'll help you keep track of negatives. So we have 2x. That's the same as 2 times 3. And then here we have minus 3. And the y is minus 2. 2 times 3 is 6. And then we have minus 3 times negative 2 is negative 6. And remember, minus minus turns that into positives. So it's 6 plus 6, which is 12. All right, here. That thingy, remember that? That is an exponent. X squared is the same thing as x times x, because it's repeated multiplication, which means 3 squared is 3 times 3. Okay, you should know that, but just in case you didn't, little refresher. All my x's become 3's, all my y's become minus 2. So 3 squared plus 2 minus 2 minus 3, and minus 2. So all I did is I just changed those variables for their substituted value. And now I have to solve. 3 squared is 9. 3 times 3 is 9. Plus 2 times negative 2 is negative 4. Minus 3 times 3 is 9. And then we still have the times negative 2. So we have 9 minus 4. And then we have minus 9 times negative 2 is minus 18. 9 minus 4 plus 18. Okay, now we just add it all together. So 9 minus 4 is 5. 5 plus 18 is 23. And that is my final answer. Let's move forward. Okay. What all this text is saying up here is this and this are exactly the same. And we know that our x is equal to minus 2. Now there are a couple different ways that you can get this. There's a smart way and there's a stupid way. We're going to do the stupid way over here. The stupid way. And we're going to do the SMRT way right here. The stupid way is just to put the minus 2 in for all the x's, and then we will have like a ton of numbers, and then we'll have to narrow it down, and it's a pain in the butt. Or the other way is we could just combine all our like terms for one easy thing to solve, and then we put in our substituted value, and it becomes way easier. Okay? Less room for error if you do it the right way. Okay. So on the left, do not simplify. On the right, do simplify. Let's check it out, and you'll see kind of how annoying and messy it is. Here we go. X is minus 2. All right, 3 minus 2. I'm assuming you already know how to do this. If you don't know how to do this, go back, because you should not be watching this if you don't know what I'm doing right now. Plus 7 minus 3 minus 2 plus 4 minus 2. I even have to go into the next block because I don't have enough room. I have to make a new line right there. Okay. 3 minus 2 is minus 6 plus minus 10 minus 3 minus times minus is plus, so that's plus 4 plus 7, and that is plus 6 plus 4 and minus 2, and then minus 8 times minus 2 is positive 16. Oops, I did positive 6. Positive 16. All right. Now I continue to narrow it down. Minus 6 and minus 10 is minus 16, and then here we got minus 19. Geez, this is fun. And then we have 4 plus 7 is 11. And then we'll add a 6 to that, and it becomes plus 17. And then we have another 4, so then we'll get plus 21. And then we get a minus 2, and then we get a plus 16. All right. Ooh, look at that. Minus 19 and minus 2 together make minus 21. And here I have a plus 21. So these are all used. And then plus 16. Ugh, what kind of 16 was that? Minus 21 plus 21 are gone. And I'm left with 16. All right. I'm pretty sure that's the right answer. But I would not be surprised if it wasn't. Because look at that. That is a whole lot of numbers. There's a whole bunch of negatives. That is a mess and a half. There's so much potential in there to make a mistake that it's crazy. Let's try it another way. I'm going to erase this part so I can see better, but you know that it was there. It was what? Minus, right up here. It was plus 8 and then minus 2. That should have been minus 16. Oh. I feel like that's not what I erased. Maybe I actually did make a mistake there. We'll have to check it against the answer. It's either, who knows? I don't even know at this point. I'm confused. All right, let's do it the other way, and we can use it to check our answer, because this way I'll get it right. All right, combine like terms. So I'm just going to, I don't have a lot of space here, so I'm just going to underline my like terms instead of circle, because I don't want to make a mistake. I have 3 plus 5, so that's 8, minus 2 is 6, and then I'm down to positive 3, and positive 3 plus 8 is 11. So I have 11x. All right, so all my x's are gone. I've dealt with all those. Great. And now I'm left with minus 3 plus 7 is 4, and then here's 8, and 8 minus 2 is 6. All right. Check this out. 11x plus 6. Substitute. 11x, which is minus 2, plus 6. 11 times negative 2 is negative 22 plus 6, and that is negative, negative 16. So this was even wrong, like I suspected. The stupid way. Don't do it that way. That's a really bad way. So much potential for error. Look, even I made an error. Don't do it. Okay. Solving one-step equations. It says, show the correct balanced steps to solve these type 1 equations. All right, remember all that stuff we've been doing in the past about opposite operations? That's all this is. Solving one-step equation is review from 7th grade. This should be very easy for you. You don't even have multiplication right here. These are all just addition and stuff. So it should be cake right now. Remember, our goal is we want to isolate our variable. We want to get it all by itself, all alone. So here we have x. We want it all by itself on this one side of the equation. And we look at what's happening to the x. Well, the x is having 6 subtracted from it. And the opposite of subtracting by 6 is adding by 6. But if you do that, you have to do it to the other side too. And when I add 6 to this side, when there's already a minus 6, those cancel out. That's the whole purpose of it. I mean, you don't have to show that every single time. As long as you're showing that you at this point understand that canceling minus 6 here is the same as adding 6, then you're good, right? Because you have to do the same thing on both sides. So now we have x equals 3 plus 6, x equals 9. All right, that was an easy one. Let's do another easy one. The opposite of minus 15 is adding 15 to both sides. Okay, and that's what I mean by correct balanced steps, because we are doing something that's balanced. We're adding 15 to both sides, which doesn't change it. And that's why we can do it, because we're still equal. That's the whole point of it, to be equal. If we add 15 to both sides, they're still equal. If you have 1 is equal to 1 and you add 15 to both sides, they're still equal. That's the whole point. All right. So if I added 15 to both sides, those are gone, and I have z is equal to minus 2 plus 15. So that's 15 minus 2, and that's 13. Okay. Here we have plus 3, so let's do minus 3 to both sides. If I do that, I have y is equal to minus 11 minus 3, so that's minus 14. Ooh, here we have a double negative. Double negative, remember, is the same as a positive here. So this, I'm going to rewrite it first. That's the same as w plus 7 is equal to 1. Got to do that first. Now we can figure out what the opposite is. The opposite operation of adding by 7 is subtracting by 7 to both sides. So those are gone. W is equal to 1 minus 7, so w is equal to minus 6. And these are all the answers on this page. Not too bad. Moving forward. Show you know. So this means that you are on the spotlight here. But you'll notice that this involves multiplication, this involves division, and that is all. We've already had experience with these, so you shouldn't have a problem. Just think opposites. You're trying to get your variable on its own. What is happening to it? This is being multiplied by 11. What's the opposite of that? Do that to both sides so that this one cancels out, and then this one has something happen to it, and the t's all alone. All right. Pause your video, work those out in your notes booklet, and then when you're ready, then you're going to check your answers against the next page. And start. There you go. Here are all the answers. Hopefully I left you enough time and they didn't just pop up on your screen, but get some practice in. Even if that did happen, go back and make sure you are able to solve all of these and they are all correct. Hopefully I didn't make any mistakes. I just did them real quick. Okay, last thing. One-step equation. We have a word problem example. So for the month of January, I'm going to underline the important stuff. The average afternoon temperature in Edmonton is 1/3. So is 1/3 the average afternoon temperature in Yellowknife. I feel like I know these kind of things, right? Is, yeah, all right. Average. So let's continue. So we got this. And the average afternoon temperature in Edmonton is -8 degrees Celsius. What is the average afternoon temperature in Yellowknife? So we're going to define the variable first. What is the variable that we need to work out? We need to write an equation that translates the word problem. So using those math words that we know, what are we trying to say? Then we balance the equation, and then we figure out what our solution means. Okay, so let's dissect this. The average afternoon temperature in Edmonton is, so let's just say E means the temperature in Edmonton, okay? E is Edmonton. Edmonton is 1/3 of the, I mean, it doesn't say of there, but we know of the afternoon average temperature in Yellowknife. So of Yellowknife. Edmonton's temperature is 1/3 of Yellowknife's temperature. Makes sense. We also know from here that Edmonton is -8 degrees Celsius. All right, and now we have to figure out the average afternoon temperature in Yellowknife. Did we define the variable? Okay, so I put a variable for Edmonton, but we don't actually need it because we know what Edmonton is. The other variable is Y. Y is Yellowknife. Okay? Write an equation that translates the word problem. We did that. Edmonton -8 is 1/3 of Yellowknife. Then we balance it. Let's rewrite that all down here. -8 Edmonton is 1/3 of Yellowknife. Now we balance it. We need to get our variable all by itself. So what we're looking at is this. What is happening to the y? It's being divided by 3. The opposite operation of dividing by 3 is multiplying by 3 on both sides. So now we have y is equal to 3 times -8. 3 times -8, ooh, that's an ugly number. That's -24. Poor Yellowknife people. All right. And now it says, what does your solution mean? Well, that means that the average afternoon, I'm not going to write it all, temp in Yellowknife is an ugly -24 degrees Celsius. Ew. -24 is their average afternoon temperature? Wow. Okay, that's just in January, but that's awful. I am never going to live in Yellowknife. And that is all for this one.